relative acceleration analysis or acceleration analysis of a rigid body mechanism using relative velocity, relative acceleration method. We did solve one simple example. After the break, we are going to solve maybe one or two more examples, and then we will be having quiz number 8. Okay, so starting with example 16-17. If you remember, we did solve this example when we were discussing the velocity analysis. और हमने इसको सॉल्व करके ये जो ओमेगास दोनों 10 रेडियंस पर सेकंड निकले हुए ये हमने वेलोसिटी एनालिसिस को परफॉर्म करके ये दोनों ओमेगास निकाले थे. डू यू रिमेंबर दैट?
Yes.
So since omegas are known to us, so we can directly start the acceleration analysis rather than first performing the velocity analysis. क्योंकि omega known है, हम acceleration से ही start कर सकते हैं. Okay, now in order to perform the acceleration analysis, we are going to start our solution from the point where the motion is known to us. So since the motion of this collar is known to us, so we are going to start with collar C. This collar is moving downward at a speed of 2 meters per second and an acceleration of 1 meter per second square. So we can write the vector AC as minus 1j meter per second square. ठीक है? Acceleration of point C हमें known है. So we have written that acceleration vector as shown to you here. Okay, then we are going to move. Sorry. We are going to move towards link CB, which is in general plane motion. So considering the next link, which is link CB, what should be the base point for relative acceleration equation? C. So the equation would become absolute acceleration of B to be equal to absolute acceleration of C plus alpha cross R, where alpha represents the angular acceleration of this link BC and R represents the relative position of B with respect to C minus omega square R BC, and this omega is going to be the angular velocity of this link, which is CB. So ये हमारे पास equation बन जाएगी. Okay, now in this case, the acceleration of point C is known to us, so we can write it as minus 1j. And as we have discussed earlier as well, that you cannot judge the direction of alpha, so you are going to assume it as alpha BCK cross RBC. What is the relative position of B with respect to C? It is going to be this vector, which has positive x, negative y. So 0.2 I minus 0.2 j. ये आपके पास alpha cross R आ जाएगा. Minus omega square, so minus 10 square into 0.2 I minus 0.2 j. ये आपके पास complete equation बन जाएगी. Once you solve it, the right hand side would become minus 1j. जहाँ तक ताल्लुक इस अल्फा क्रॉस आर का है, तो अगर हम फर्स्ट टर्म की बात करें, इट इज गोइंग टू बी 0.2 अल्फा BC k क्रॉस I इज j, तो दिस वुड बिकम j और ये पॉजिटिव साइन आएगा. सेकंड केस में आपका ये नेगेटिव साइन है, 0.2 अल्फा BC and k cross j would become minus I, so this would become plus I. And further ये right side पे जो टर्म है 100, 10 square आपका 100 हो जाएगा multiply by 0.2, so it is going to be minus 20 I plus 20 j. ठीक है, let me call it as equation number 1, and this represents the acceleration of point B. Clear है यहाँ तक?
Yes, sir.
Okay, now moving on to the next link, which is link AB. So in order to apply the acceleration equation, first of all, what type of motion this link AB is undergoing?
Pure rotation about A.
So, pure rotation about point A. So if we want to write the acceleration of point B with respect to this link AB, what should be the equation?
Sir, alpha cross R minus omega square R.
So it is alpha cross R minus omega square R, but here alpha is going to be alpha AB, R is going to be the absolute position vector RB, omega is going to be the angular velocity of this link AB, and R is going to be the absolute position vector. Okay, so can you again judge alpha AB?
No, sir.
So you are going to assume it as alpha ABK cross RB. What is RB here?
Minus 0.2 J.
So minus 0.2 J minus 10 square minus 0.2 J, and further solving it आपके पास जो further solution आएगा alpha cross R minus 0.2 alpha AB, K cross J is basically minus I, so it would become positive. So 0.2 alpha ABI ये आपके पास एक टर्म हो जाएगी, and the second term would be minus minus plus हो जाएगा 10 square which is 100 into 0.2, so 20 J आपके पास आ जाएगा, so plus 20 J. So let me call it as equation number 2. ठीक है, तो ये आपके पास दो equations आ गई हैं. Since it is a vector equation and both of them represents the absolute velocity of B, so comparing 1 and 2 and then comparing the coefficients on both sides of this equation, if you compare the I coefficient, it would be 0.2 alpha AB should be equal to 0.2 alpha BC minus 20. Once you compare the J coefficients, it means that 20, which is on the left hand side with J, would be equal to minus 1 plus 0.2 alpha BC plus 20. So how many unknowns are there in these two equations, 3 or 4? में कितने unknowns हैं?
Two unknowns.
We have two unknowns, the angular accelerations of length AB and length BC. So once you solve these two equations, you are going to get alpha BC to be equal to 5 radians per second square and alpha AB to be equal to minus 95 radians per second square. What does that negative sign with alpha AB represents?
Our assumed direction was incorrect.
Yeah, so we assumed initially alpha AB to be in a counterclockwise direction. This negative sign indicates that alpha AB is in fact in a clockwise direction. However, alpha BC comes out to be positive, which means that our assumption is correct, and alpha BC is basically along the counterclockwise direction. Is it clear to all of you?
Yes, sir.
Any query which you want to ask regarding example 16-17? Okay, so moving on to the final example of today's lecture, which is example 16-18. A mechanism of this type is being shown to you. Okay, can you identify आपने ये mechanism जो नजर आ रहा है फिगर में, क्या इसके हवाले से कहीं पढ़ा है, ये कहाँ इस्तेमाल होता है?
Piston.
जी, पिस्टन तो है, लेकिन ये पूरा मैकेनिज्म अगर हम कहें तो ये कहाँ आपने कोई किसी सब्जेक्ट में पढ़ा है कि कौन से मैकेनिकल मशीन में ये हम इसको इस्तेमाल करते हैं?
हाइड्रोलिक मशीन्स.
हाइड्रोलिक मशीन्स में भी होता है, और मेनली आपकी जो गाड़ी के इंजन होते हैं उस जी गाड़ी कार के जो इंजन होते हैं उसमें इस्तेमाल होता है. इसमें लिंक ए बी जो है वो आपका क्रैंक कहलाता है, बी सी कनेक्टिंग रॉड है, और सी जो है वो पिस्टन है जो कि सिलेंडर में मूव करता है. और उसी हिसाब से आपके जितने एस आई इंजन या सी आई इंजन है उसमें ऑलमोस्ट यही मैकेनिज्म जो है वो इस्तेमाल किया जा रहा होता है. सो इन दिस केस ए बी इज द क्रैंक विच इज रोटेटिंग विद द मोशन शोन, दैट इज omega AB आपको given है 10 radians per second and alpha AB is given to you as 20 radians per second square, both in a clockwise direction. So चूंकि alpha AB और omega AB दोनों एक ही direction में, it means that the crank is angularly accelerating at the instant shown. इस इंस्टेंट के लिए आपको जो कनेक्टिंग रॉड है लिंक BC उसकी भी angular velocity known है, which is 2.43 radians per second. You are being asked to determine the acceleration of the piston at the instant AB is in the position shown. At this instant, omega AB is 10 radians per second and omega BC is 2.43 radians per second. So is the question clear to all of you?
Yes, sir.
Okay, so what type of motion these links are undergoing? अगर मैं piston C की बात करूं तो ये कौन सा motion है?
Sir, translating.
And what about link AB?
Pure rotation.
Rotation about A. And what about link CB?
General plane.
It is in general plane motion. Okay, so the data of link AB is given to us. So we are going to start from link AB, but probably We would be requiring some radii which are going to be used here. Probably we would be requiring this position vector, which is position vector RB. So can you identify first of all what this position vector RB would be? Quadrant कौन सा है?
Second quadrant.
It is in the third quadrant, so negative x, positive y. Angle is given to you 45 degrees with respect to the y-axis. So the cos component is going to be with y. Although 45 से कोई फर्क नहीं पड़ेगा, लेकिन generally angle चूंकि y से given है तो cos component y के साथ आएगा और आपके पास sin component जो है वो x के साथ आ जाएगा. So overall it is going to be minus 0.25 sin 45y plus 0.25 cos 45j. Clear है ये चीज?
Yes, sir.
So it would become minus 0.177i plus 0.177j. Okay, the other position vector, मैं इसलिए पहले लिख रहा हूँ कि बार बार आपको ये position vector इसमें इस्तेमाल करने होंगे. The other position vector which you would be requiring here is basically this vector, which is the relative position of C with respect to B. So what should be this position vector RCB would be?
Third quadrant.
Third quadrant or first quadrant?
First quadrant is 0.75 cos 13.6.
So it is going to be first quadrant. It means कि positive दोनों आएंगे x और y आपके पास, और चूंकि एंगल आपको 13.6 गिवन है y से, तो cos component y के साथ आ जाएगा, sin component जो है वो x के साथ आ जाएगा. So overall this RCB vector would become 0.176i plus 0.729j. Units in दोनों vectors के fit हो जाएंगे. Okay, so after applying the vector, from which link we are going to start our solution?
Link AB.
So we are going to start our solution with link AB, which is in pure rotation. So what should be the velocity, what should be the acceleration of B?
Omega cross R plus
Acceleration की बात कर रहे हैं.
alpha cross R.
Omega किधर से आ गई acceleration में?
Alpha cross
Alpha cross R minus.
So it is going to be alpha cross R minus omega square R. So AB is going to be alpha cross R minus omega square R, and alpha is basically alpha AB. Similarly, omega is going to be omega AB. As far as this position vector is concerned, it is going to be the absolute position of B with respect to A. So alpha cross R minus omega square R. Alpha again जज कर, सॉरी अल्फा तो गिवन है आपको, क्या अल्फा बन जाएगा वेक्टर फॉर्म में? क्लॉकवाइज है, काउंटर क्लॉकवाइज है?
Clockwise.
So it would become minus 20k cross RB, which is 0.177i plus 0.177j. ठीक है, ये आपके पास अल्फा क्रॉस R हो गए, माइनस ओमेगा सॉरी आई वाला नेगेटिव है, आप सही कह रहे हैं. सो लेट मी पुट अ नेगेटिव साइन हियर. ठीक है, सो माइनस 0.177i प्लस 0.177j. ओके, माइनस ओमेगा स्क्वायर, ओमेगा आपको गिवन है विच इज 10, सो इट इज गोइंग टू बी 10 स्क्वायर टाइम्स the same r, which is minus 0.177 plus 0.177j. So overall, once you take this cross product, AB would comes out to be 21.24i minus 14.6j feet per second square. Okay, what should be our next step?
Link BC ले लेंगे.
Okay, so what should be our base point for this link?
B.
Since the motion of point B is now known to us, so we are going to take B as our base point. The equation would become AC equal to AB plus alpha cross R minus omega square R. Now AB हमने already find कर लिया था, which was 21.24i minus 14.6j. Alpha हमने assume किया कि alpha BC is in a counterclockwise direction, so we have written it here as alpha BCK. RCB हमने already at the start जो है वो लिख लिया था, which was 0.176i plus 0.729j. ओमेगा हमें known थी, which is 2.43. into R. Okay, now coming to the left hand side, since the left hand side represents the absolute velocity of this piston, and if this link is rotating in a counterclockwise direction, then definitely C would be moving upwards. So we have assumed this AC to be equal to ACJ. Clear है ये चीज? So यहाँ हमने AC की जगह ACJ लिख ली है, and then comparing the I and J coefficients on both sides of this equation. When you compare the I coefficients, you are going to get this equation. When you compare the J coefficients, you are going to get this equation. The number of unknowns here are, one is alpha BC, the other one is AC. These are the two unknown quantities in these equations. So solving these two equations simultaneously will give you the values of alpha and AC, which comes out to be 27.71 and minus 13.6 feet per second square. Since alpha comes out to be a positive quantity, it means that our assumption regarding angular acceleration of BC was correct, and this link is moving with this much of alpha. However, AC comes out to be a negative quantity. Now, what does this negative quantity represents?
Downwards move कर रहा है.
एक्चुअली मैं यही जवाब सुनना चाह रहा था. अगर तो VC मेरे पास नेगेटिव आ जाता, मैंने ऊपर अज्यूम किया होता और VC नेगेटिव आ जाता, तब तो मैं कह सकता था कि पिस्टन इज मूविंग डाउनवर्ड. लेकिन यहाँ AC नेगेटिव आने का मतलब हरगिज ये नहीं है कि पिस्टन डाउनवर्ड मूव कर रहे हैं. हाउएवर नेगेटिव आने का क्या मतलब है कि पिस्टन तो ऊपर ही मूव कर रहा होगा, एक्सेलरेशन इसकी डाउनवर्ड आ गई है. इट मींस ये क्या हो रहा है, डिसेलरेट हो रहा है. ठीक है. सो एट द इंस्टेंट शोन this piston is basically decelerating rather than accelerating. Velocity तो इसकी हर हाल में ऊपर की तरफ ही आएगी. ठीक है. Is this point clear to all of you?
Yes sir.
Yes.
चलिए, तो वैसे भी 10 बज गए. We are going to stop here. I hope कि ये आसान वाली एग्जांपल्स आपको समझ आ गई. इंशाल्लाह नेक्स्ट वीक का जो लेक्चर हमारा होगा उसमें हम थोड़ा सा ये मुश्किल वाली प्रॉब्लम्स देखेंगे कि किस तरह इन मैकेनिज्म से हम वेलोसिटी और एक्सेलरेशन एनालिसिस जो है वो परफॉर्म करते हैं. और उसके बाद काइनेटिक्स के जो टॉपिक्स रह गए हम थोड़ा सा उनको भी इंट्रोडक्शन उसका जो है वो देख लेंगे इंशाल्लाह नेक्स्ट वीक.